Okay, in this lesson, we are going to be solving problems using combination. All right, so in one of the previous videos, you learned what the combination and the permutation formula is. This lesson, we're just going to dive deeper into combinations. So right here, just some review stuff. The notation for combinations, it can be written lots of different ways. There's actually a third way on here that I did not put. So you could write it as NCR. You could write it as C parentheses in comma R, or you can even write it as C and then parentheses N on top, R on the bottom. Those are three different ways that you can write this. We read it as N choose R, like that. So in my example right here, if I have 5C3, this is read as 5 choose 3. And at this point, you should know, now that you've practiced with the formula a little bit, you should know that that means out of 5 selections, we are choosing 3 of them. And this formula helps us calculate how many possible ways is there to choose 3 out of a group of 5. All right, very good. Last, some important notes. For combinations, order does not matter. Combinations are less than equivalent permutations, meaning that uh, 5p3 is going to be bigger than 5c3. And then your R value, the amount you're choosing, must always be less than your N value, the total amount. Okay? You can't do like 5 choose 6. It won't work because you can't pick 6 people out of a group of 5. All right. I think the best way to just dive into this is to just look at some problems. So right here, first one says a public committee of 3 people is to be elected from a group of 2 male candidates and 3 female candidates. What is the probability that the committee will consist of 1 man and 2 women? Okay, so this problem actually blends a couple ideas together. It blends combinations and the multiplication rule, or the fundamental counting principle. So first thing is I am choosing 1 man out of a group of 2 men. All right. So the first thing I'm going to do is figure out what 2 choose 1 is. Okay. And this is for the male candidates. Then I'm going to multiply it by the women. All right. Remember, the multiplication rule is you take the number of outcomes from one event, you multiply it by the number of outcomes from another event, and you get the total number of possible outcomes. Okay, so for the women, we are picking 2 out of a group of 3. So I need to figure out what 3 choose 2 is. Okay, and I can do that over here. So if I let N be 2 and I let R be 1 for the male candidates, then I have 2 factorial over 1 factorial times 2 minus 1 factorial. Okay, and that is equal to 2 times 1 on the top, divided by 1 factorial is just 1. And then right here, 2 minus 1 factorial, that's also just 1 factorial, so times 1. So I end up with 2 over 1, which is 2. There are 2 possible ways to pick a male candidate. Okay, now for the females, okay, we're going to let N be 3, because there's 3 possible females. We're going to let R be 2. We're picking 2 of them. And so now I have 3 factorial divided by 2 factorial times 3 minus 2 factorial. And that's going to be equal to 3 times 2 times 1 on the top. On the bottom, 2 factorial is 2 times 1. And then 3 minus 2 is 1 factorial, so this is times 1 again. All right, and hopefully you see that the 2's cancel, one of the 1's cancel, and I'm left with 3 over 1, which is 3 possible ways. All right. So now what I need to do is I need to multiply those two possible outcomes together. So there are two possible ways to pick males, three possible ways to pick females, for a total of six possible ways. Now, normally I would be done. However, it says, what is the probability that the committee will consist of one man and two women? So remember, probability is number of outcomes I want divided by total possible. So this is the number of outcomes I want. So this is the top of my fraction. To figure out the bottom of my fraction, I need to figure out the total possible number of outcomes. Well, that would be if I were to ignore the fact that they're male and female. And I would say, okay, this is a total group of 5, and I want to pick 3 of them. 1 man, 2 women, that's 3 people. So to find my total outcomes, okay, I need to let n be 5, because there are 5 possible people, and I need to choose 3 of them. So I'm going to do 5 factorial divided by 3 factorial times 5 minus 3 factorial. Okay, on the top, this is 5 times 4 times 3 times 2 times 1. On the bottom, we have 3 times 2 times 1. And then 5 minus 3 is 2. So 2 factorial is 2 times 1. Okay, once again, 3's are going to cancel, one of the 2's are going to cancel, and one of the 1's are going to cancel. So I'm left with 5 times 4 divided by 2 times 1. This is 20 over 2, or 10 possible outcomes. All right, so to finish the problem, to calculate the probability, I need to do the probability is equal to the outcomes I want, which are 6, divided by the outcomes, the total possible, which is 10. And if I plug 6 over 10 into a calculator, I get 0.6, or this is a 60% chance. So there is a 60% chance that if I form my committee, I'll have 1 man and 2 women on my committee. All right, very good. In the next problem, okay, so again, we're working with a combination here. Means the order does not matter. So again, right here at the top, it does not matter what order I pick the man in and what order I pick the 2 women in. Okay, as long as I have 1 male and 2 women, I'm good. All right, now for this one, it says a broadcasting director is scheduling commercials for a sponsor. There are 6 time slots available to air commercials. How many ways can the commercials be scheduled if the sponsor has 3 different commercials, each to be viewed twice? We're looking at part A here. All right, so this one's kind of weird. For this one, because there are 3 different commercials, this lets me know that I need to break up these 6 time slots into 3 different groups. All right. Each of them are going to be viewed twice. So basically, we have 6 slots. All right. So I can draw a quick picture here. Okay, commercial A is going to be going into 2 of them. And it does not matter which 2. That's part of why this is a combination. Commercial B is going to go into 2 of them. And then commercial C is going to go into 2 of them. All right, so really I have 3 different combinations going on here, and each time I'm choosing 2 different slots. All right, so kind of the theory behind this one is I'm going to start with all 6 slots, and I'm going to choose 2 of them to run 1 commercial. Then I'm going to multiply that by, there are now 4 slots remaining, and again, I'm going to choose 2 more of them. And then finally, I need to multiply that by the remaining 2 slots, and I'm going to choose both of them. So I need to figure out what each of these are, all right? Okay, so 6 choose 2. Actually, go ahead, pause the video, try it yourself. I will give you the answer to this problem in 5, 4, 3, 2, 1. Okay, so once again, we just use our formula. So that's what I've done here. I've set it up. I've simplified it a little bit right here. And then I've used the shortcut from the previous video to simplify it even more. So remember, you're going to pick, for each fraction, you're going to pick the largest factorial on the bottom. So in this case right here, I have 4 factorial in this first fraction. And I'm going to start writing out the top, 6 times 5 times 4, all the way down. But once I hit that largest number on the bottom, I'm going to stop. So 6 times 5, and I'm not going to go to 4. And then that 4 on the bottom just cancels. So I'm left with only 2 factorial on the bottom. So I did that shortcut for these first 2 fractions. For this last fraction, I wrote it all out just so you could see something. 2 factorial on the top is 2 times 1. 2 factorial on the bottom is still 2 times 1. And then remember, 0 factorial is weird. 0 factorial is 1. So this is 2 times 1 on the top divided by 2 times 1 times 1 on the bottom. Okay, when I simplify and do all the math, I end up with 15 times 6 times 1, which there are 90 possible ways that the sponsor can schedule these commercials. Okay, now, again, I want you to pause the video. I want you to try it again. This time, the sponsor has 2 different commercials, each to be viewed 3 times. So remember, your hint is this tells you how many combinations you're going to have to do. And this tells you how many how many of the commercial slots you're choosing each time. So go ahead and try it on your own. I will give the answer in 5, 4, 3, 2. Okay, so the way you should have set this one up is 2 different combinations for each of the different commercials. And each time we're picking 3 slots to run them in. So first, out of all 6 slots, we're going to pick 3 of them to run the first commercial. Then we're going to multiply that by the 3 remaining slots. We're going to choose all 3 of them to run the commercial. Now, hopefully you've noticed that 2 choose 2, 3 choose 3, both of those just end up being 1. That's because if you have a group and you're picking everyone in the group, there's only one possible way for you to do that. Okay. Yeah, so when you do the math on this, you should have gotten 20 different ways to run these commercials. Okay, flip over to the back. We got 2 more problems to try. So number 3, it says, what is the probability that a football team that plays 10 games this season will have 6 wins and 4 losses? Solve this problem 2 different ways, all right? So what I mean by solve this problem 2 different ways is this is really similar to the commercial one. We have 2 different types of outcomes. We have wins and we have losses. So that means I need to do 2 different kinds of combinations. However, it's a different number of wins and losses. So the way you would solve a problem like this 2 different ways is first you could do wins then losses, okay? So I could say out of 10 games, I'm going to choose 6 to win. Then I'm going to multiply that by out of the 4 remaining games, I'm going to choose 4 to win, or 4 to lose, sorry. So that's one way we could solve this. You could also solve it the other way, where you do losses first. All right, so when we do losses first, we could say out of 10 games, we're going to choose 4 to lose. And then out of the remaining 6 games, we're going to choose all 6 to win. Okay? And the reason I'm having you do it 2 different ways is because hopefully when you do the math on both of these, you see that you get the exact same answer. So I want you to go ahead and try it both ways. And once again, I will give you the answer in 5, 4, 3, 2, 1. Okay, so here we go. Here's all the math for this. You do 10 choose 6 for this first way times 4 choose 4, and I've just used the formula. Then simplifying a little bit, I get 10 factorial divided by 6 factorial times 4 factorial, and then times 1, because remember 4 choose 4, that's just going to be 1. Okay, I end up with this fraction here, which simplifies to 5,040 divided by 24, there are 210 possible ways to get 6 wins and 4 losses. All right, great. Now, let's see down here. Same thing, right? When I do 10, choose 4 instead, so I do the losses first, okay? What's going to end up happening is I set this up, and I'm using 10 factorial and 4 factorial now, but if you notice, we end up with the exact same fraction that we did in the previous problem, okay? So what this tells you about combinations is that order truly doesn't matter. If you do wins versus then losses, you're going to get the same answer as losses first then wins. You're going to end up in the same spot. There's still 210 games where we have 6 wins and 4 losses. All right, now before we move on, we were asked to find the probability that during a season we have 6 wins and 4 losses. So remember, probability is going to be the outcomes we want, 210, divided by the total outcomes. So to figure out all the total possible outcomes of this football season, this is the fundamental counting principle, right? So you have 10 games, all right? And each of them have 2 possible outcomes, either a win or a loss. So we would say the total number of outcomes is going to be 2 choices for the first game times 2 choices for the second game times 2 possibilities for the third game, on and on and on, all the way to 10. All right. So 2 times 2 times 2 times 2 times 2, 10 times. In other words, this is 2 to the 10th. So there are 10 of these. And if we put 2 to the 10th in a calculator, we're going to get 1,024 possible ways that this season could go. All right. So my total probability then of getting 6 wins and 4 losses is going to be equal to the number of outcomes in which that occurs. So there are 210 possibilities where I have 6 wins and 4 losses, divided by the total number of outcomes, just like that. And once again, when we put that in a calculator, we are going to get approximately 0.205. All right. So, in other words, a 20.5% chance that the season will end with 6 wins and 4 losses. Okay, very good. Let's look at the last problem now. It says Coach Connor owns 4 pairs of pants, 7 shirts, 5 hoodies, and 3 pairs of shoes. In how many ways can he pack 2 pairs of pants, 3 shirts, 2 hoodies, and a pair of shoes for an upcoming trip? At this point, hopefully you know how to do this problem. So I'm just kind of going to set you up and then give you the answer. Remember, each of these different categories, so we have pants, shirts, hoodies, and shoes, so 4 categories. That tells us how many combinations we're going to do, all right? And then out of each of those categories, this sentence that I'm going to highlight for you, this sentence right here, maybe, good grief. This tells us what we're choosing out of each combination, all right? So for the first one, I've got 4 pairs of pants. I'm choosing 2 of them. Then I'm going to multiply that by, I've got 7 shirts. I'm choosing 3 of them. Then I'm going to multiply that by, it looks like I have 5 hoodies. I'm choosing 2 of them. And then finally, I have 3 pairs of shoes, and I'm only choosing 1 of them. So if you can set up each of these formulas and then multiply them all together, you will have your answer to this problem. And once again, I will give the answer in 5, 4, 3, 2. All right, so if you set up all these fractions, simplified, and did all the math, you should have gotten that there are 6,300 possible ways for me to pack for this trip. All right, that's it for this lesson. In the next one, we'll look at permutations.